Hello. I'm going to be answering a question over on the Slack channel today. I got regarding, well, this person's uh, project. So, from what I understand, um, there is an issue regarding um, pins. So, you're trying to get it as optimized as possible because of error rate in transmission. So something to do with the performance of writing to the pin, which is why you came up with this abstraction, which is hardly an abstraction now that I mention it, now I think of it. Um, so the way you're writing pin values, pin logical levels, so high voltage, low voltage, is by directly using the register to set a mask, and that's extremely performant. You don't get any more performant than that. That's like a single instruction, um, unless you go the DMA way, right? So if you have an interface which allows for DMA access, you can give in better performance because this you get the CPU out of the way basically. Um, so the just for let it be clear, I am not familiar with other DMA interfaces on other CPUs. I know of the RP2040 and RP2350, so that's where I know, that's where I'm in my element. Anyway, let's read the so here you send me your repo. You suggest DMA. So you're still having issues. It looks like you're on your way to implement these other functions. Okay. From my understanding, you're still trying to get the performance up on writing that pin. That's like your main goal. So let me start with some general just first impressions of this repo. Well, first thing I noticed, I think I opened Minicat and I noticed straight away this was not Go formatted, because I saw this var declaration right above the func input. So this is clearly, so if I press Control S, boom, my editor has auto formatting. I suggest you allow for auto formatting, you enable it. It'll, I think it's quite useful for like just not spending too much time indenting code and whatnot. It really speeds up development in my experience. Next up, well, I wanted to jump into the function, which you mentioned, the read register function. So, okay, it looks like here you're checking if it's reg is greater than 46 and less than 62. So if it's in range, it's going to be burst. Again, Go format. Look at this extra tab. If I press Control S, boom, auto formatted. This also helps reduce the amount of diff in changes, because if all your contributors use GoFumped is the official name, then you'll never get anyone like mistyping a tab, deleting a tab by mistake, and have that appear in the diff. It just doesn't happen. So it has its functional side during collaborative work. Anyways, boom. Okay, it's either burst or single. Here you allocate. Here you're allocating again, because I mean the compiler can maybe infer these are going to be on the stack, but then you do this, and spy is an interface. Oh, it isn't an interface. Interesting. So you went the route of using a concrete type, a machine.spy. Usually when we write drivers in TinyGo drivers repository, we use the interface abstraction. In any case, this might escape or not to the heap. It might cause performance slowdown. So I guess I'll make another video with the changes I suggest. I'm just gonna note them here and then I'll write them just so I don't take too much time. Reg burst, tx. So spy usually has this method, right? The transfer. You can use that if you're going to transmit a single byte. So this could become, that's the write section. So TMP, that becomes that. And then you do the data. That is equivalent. Strobe, TX. Okay, cool. Yeah, notice how much changes GoFumt has applied. It's changed all these lines which are marked in yellow off to the side. Write reg, okay. So here it seems you're writing a UN32. Maybe, oh, never mind. It's not. It's just a 24-bit number. I was about to think maybe adding a 32-bit write reg, but that wouldn't work if it's 24 bits you're writing. Anyways, and are they sequential? 15, 14, 13. Oh, interesting. Just they're descending. Anyways, off to set here. Modulation. This looks all good. Standby does a strobe. Also, these fours are. Oh, you're forever blocking in here. If you know, this could be a panic. Gets pretty much the same thing done. Or if you're looking for this behavior specifically, you can abstract this into a function, which you then change project-wide. You know, func panic 2 as string. And then here you can either use panic or println s for. So, and you replace all these, right? Panic 2. Bit rate. Range. In general in Go, that said, in general in Go we return an error here instead of, you know, panicking. Because this is a very reasonable error. I mean, the user used a bit rate that was not in the range. Yeah, just here we do return errors.new bit rate out of range. And this would be a much better approach because you have error handling, and that's, you know, just a great thing overall. Let's continue. Of course, when it succeeds, you return nil. Do the same here. Return an error. If we continue, same here. Like, this is invalid. This should be an error. Yeah. User can easily pass in an invalid value. You should return an error in these cases. Yeah, there's plenty of material online about Go error handling if you search it up. Yeah, looks reasonable. Oh, this. Yeah, that's what I was picking up. So you can simplify lots of these if statements. Like in Go, you return an error. So what usually happens is you have an errorly return. It looks something like this. and you do away with the else clause. You simplify the code, you reduce the indentation level, which kind of makes it easier to read, or at least just more expected, readable in the sense that, all Go code usually looks the same because, we Gophers like to omit the else statement. So you end up with something that looks the same, everywhere you go. Same thing here. This should be an error. This should be an error. Should this be an error? Yes, there should be an error. I'd actually invite you to read my LoRa driver, which I feel has a lot of lessons you could borrow from. It's got the device LoRa. This would be your radio type. It's got the SPI bus, and you have your config struct, which always return those errors. And I've defined these errors as global variables. What this allows me to do is not allocate every time I return an error. So this is a good repo with great lessons learned. You got good stuff here. Write 8. This is pretty much your write register. It does allocate though, so this isn't great. Not great, not terrible. I guess I've made mistakes as well in my past. Anyways, let's continue with your repo. This table, if it's not a global variable, it's allocated on the stack. So, and the way you're using it, should it be on the stack? Oh, maybe it should. You're kind of like accessing the whole. Okay, maybe it makes sense to have it on stack, because this is a for loop. You're not just accessing once, so you're accessing 8 times. Okay, sure. Carrier sense. This is all good. Again, error type. Return those errors. And I think that's it. Parse signed int a to I. Oops. I think there's a parse. I think parse int is better because you can tell it the bit size, so that this doesn't underflow. Yeah, overflow would be. This will return 0 if your number is greater than a 32-bit number, and an error, which you can return. So, which you're using in set output power. Wait, what? How are you using this? Input. Oh, okay, the user inputs. Okay, you got like a serial interface going on here. Very nice. Pretty cool. And I'd use 64-bit ints because that's what the Go library, defaults to, returning those integers. Other than that, this looks good. Hope that was useful.